Welcome back sa ato ang class. This is a continuation sa topic nato ang separation of variables. So, previously we discussed the separation of variables uh, in Cartesian coordinates, and this is one of the special techniques that is used to calculate for the potential, okay, in any given system. Let's proceed. So, let me just okay. So, for spherical coordinates, we will assume we will assume that which is ano po siya, reasonable. Assume it has azimuthal symmetry. Okay, so why it has azimuthal symmetry? Well, it's simple. So if you have your sphere, and this is radius r, so at any given point, let's say kani siya nga point, so ang iyang potential potential by the way is the work needed for this charge to bring from infinity padulong sa kana nga point, right? Padulong sa kana nga point. So, we know nga ang potential is conservative. So, it's not dependent on the path, but it's only dependent on the initial and the final point. So, it's somehow like this. Ang iyang potential is na siya azimuthal symmetry because mo depend lang siya sa angle theta, what is this theta, and it does not depend on the azimuthal kana bitong mo siya i-rotate diha. So anywhere di mo siya i-rotate, actually the same ra iyang potential, right? So ang iyang potential with respect to the azimuthal symmetry is the same. So it only depends on kani nga angle katong theta bitaw. Diba katong sa ato ang uh, spherical polar. So we have um, let's say kani siya nga point, right? So this is theta and this is p. So somehow when we try to calculate for the potential in a spherical polar coordinates, automatic it has actually azimuthal symmetry. So ang iyang potential it doesn't depend on the phi or phi nga angle, but only depends on theta and of course the r. I hope that is clear. So calculating for the Laplace equation in spherical polar coordinates would be easier because we will only be dealing with uh, will be dealing only will be dealing only the Laplace equation in terms of two dimensions. So r and theta lang. So recall the Laplace equation. You have Laplace equation in spherical polar coordinates. It's given by this form or expression. Ah, should be sine theta 1 equal 0. So that is our Laplace equation in spherical polar coordinates in terms of r and theta only with azimuthal symmetry na siya. So again, to simplify this expression in such a way that the first term um, contains only the r square in terms of r, and the second term should only contain the theta. So we'll find a way nga mawala ni siya para ang kaning second term is in terms of theta na lang. So in order to do that, you have to multiply the whole equation with r square. Right? In that way, mahimo siyang so, 1 over sine theta na lang ni siya din sine theta theta. So, sine theta, 1 over sine theta na lang mabiling. So, in terms of theta na lang ang, of course, ang second term, while the first term is in terms of r square only. So that, ma-introduce na to ang separation of variable na solution. So, we'll say, let's say the solution is, kani, say ang solution kay kana, v of r theta, r of theta, then say alpha of theta. So, ang solution is separated siya, two separate variables, entirely separate. We have in terms of r only and in terms of theta only, given by alpha. Okay? So, the same process gihapon as we did before sa Cartesian coordinate, we'll substitute this v solution sa atong Laplace equation so that we get oh, r of r sa'yo. Sorry about that. Okay. This is r of r. Okay. Then theta, alpha of theta. This is r of r over r plus 1 over sine theta, partial of theta, quantity sine theta, partial of r, alpha of theta over partial with respect to derivative with respect to theta. And then this is equated to 0. Okay. So next is, since kaning first term, this first term is taking the derivative with respect to r. So alpha of theta will be taken out sa imuhang derivative. Same thing is true with the second term in terms of theta na siya. So magawas nimo ang r of r because constant kasi yan. So we can multiply the whole thing by this factor. So similar lagi siya sa previous na process. Okay. So we have, so since multiply nimo na siya, magawas man ning alpha of theta, di ba? So cancel siya. But we are left with 1 over, so in terms of r gina siya. Okay. Oh, yeah, tama. So this is r of r with respect to r plus, so this will become 1 over alpha of theta sine theta. Okay. And then sine theta partial of alpha theta with respect to theta. Okay. So since ang imuhang first term is in terms only of r and the second term is in terms only of theta, so the only way nga masatisfy ni siya nga equation is that this must be equated to some kind of a constant. So dapat constant na siya. And this is also a constant. And this constant, later on, actually nalay reason nga nung kana. So baga na-foresee na nadaan ba nga, that should be the form of a constant to satisfy some kind of a relation or equation para sa yun siya isolve. Later on, ito na makita. So this constant should be equated to m m plus 1. And this constant should be equated as m, a negative m of the first constant. Okay? Para pag i-add nimo, it will be equated to 0. Okay? So we have this form now. And consider the solution of the first term. So similar niya sa katong Cartesian actually. So let's consider the solution of that first term as this. Consider the solution of r as this one. R of r equals a r of k. So baka it's a guess ba? Actually it's a highly intelligent guess. It turns out nga sakto na siya. Okay, so that will be the solution of r, the first term. There's one way to check that if we substitute this one, if we substitute it here. Okay, so mahimo na siyang 1 over a to the rk, right? Partial r. This is a r to the k. Okay, and then what happens next is mahimo na siyang 1 over a r to the k r squared. So if it take na to ang derivative ana, that would be a naog ang k, right? R to the k minus 1. And then kanis siya is constant raman na, no? So magawas nato na siya. That would be 1 over, that would be a k, a r to the k, partial of r. Kanis siya og kana mausa man na, diba? Because the same naman sila nga base r. So that would be r to the k plus 1. Okay? And then that would be easy to take the derivative. So cancel lang a. That would mean we have k r to the k. So the derivative of that is we have k plus 1, right? Then r to the k. So cancel na siya, cancel. So this would be equated to, so ang result niya is tama niya. K plus 1, which is muna siya ang katong constant na to. Katong m plus 1. Okay? So this would be m plus 1. So we can actually get the relationship between k and m. So mahimo na siyang this is k squared plus k, tama, minus m plus 1 equals 0. So to get k in terms of m, we'll treat this k constant man siya, right? This is constant. We can use a quadratic formula to get the k. So k is equal to the negative. You can review your quadratic formula. So you have negative 1 plus and minus. Ang formula sa quadratic formula is, if you can recall the quadratic formula, let's say x is equal to the negative b plus minus 4ac over 2a. Oh, sayop. This should be b squared minus 4ac over 2a, where x squared plus a squared plus bx plus c equals 0. Okay, muna ang solution. So, ato na siyang i-apply din here. Tama? So, that would be negative 1 plus and minus 1 plus 4 times m plus 1 over 2. Okay, so that would be negative 1 plus and minus. So, this would be, actually, mo siya i-simplify. This becomes imo siya i-distribute, we have 4m squared plus 4m plus 1. Okay? I hope naka-follow ra. 1, negative 1 plus and minus. This one is actually 2m plus 1 squared. Okay? I hope naka-follow ra. So that would be 2. So this is negative 1 plus and minus. So ang result ano niya is just 2m plus 1, right? Therefore, ang k nimo is duha iyang value. We have m or negative 2m minus 1 over 2. Okay? So I hope ma you can actually see that. Okay, let's review. So if plus ni siya, if let's say kani siya, if plus, so you'll get m. But if it's minus, I guess it should be this. It should be if it's minus, so negative 2m minus 2 over 2, or that's negative m plus 1. So duha ang imong result could be m or negative m plus 1. Okay? So that would be the solution nimo. So the solution sa R is therefore a to the rk man to, diba? So that would be a to the rm, where k equals m or negative m plus 1. We have b over r to the m plus 1. So ako lang ginaog ang m plus 1 because that's to the negative mo na siya. So this would be the solution sa r. Okay? Then we'll consider the second part, okay? Katong this one, katong angular part. Okay? For the angular part, we have this 1 over alpha theta sine theta. So this is equated to negative m plus 1. Okay? So the solution actually here is a Legendre, is in terms of Legendre polynomial. So let me take a look at this Legendre polynomial. So I think naka-encounter na mo before og Legendre polynomial. Ang iyang equation actually is given by this. And this conditional equation is, ang solution niya is really known as the Legendre polynomials. So I have here with me, ato ko sa Wikipedia, and take a look at the Legendre polynomials. Okay? And the equation is given by this. So equation 1 is really familiar. Muna siya nga equation, right? This equation is actually this. Okay? So n lang din ni katwa is m. Okay? And a solution niya is given by p. So we have this in solution. Tada. This one, the first few Legendre polynomial. Sa ito nga case is cosine lang to siya or sine. Just replace x with cosine. Okay? Going back. So the solution for this equation, oh, this equation is given in terms of Legendre polynomials. Okay, so it's given in terms of Legendre polynomials. And Legendre polynomials has properties. So na ay properties ang Legendre polynomials. So the first property is if m is even, then we have this property sa Legendre polynomial. The same siya. Okay. Even if it's negative, if it's even ang m, then pareha sila og form solution. Okay, pareha sila og form. If m is odd, so ma-negative na siya. Okay, magawas ang negative sign. Okay. Then so if x is 1, so that's actually 1 for all m. Then the last thing is these Legendre polynomial are orthogonal to each other. Okay. And this is n, this is n. So orthogonal siya nga polynomial. In that way, nara kay result if n equals m. Okay, otherwise, wala siya. We have 2 over 2m plus 1, then we have the Kronecker delta mn. So m should be equal to n. Or we have negative 1 to 1 in terms of cosine theta. Okay. So the solution, so the taas naman na siya din. Tingnan na lang ta. Therefore, the solution is just katong combination sa r o sa theta. Okay, separation of variables man ta. So we have v r theta equals, then isama nimo siya sa tanan nga possible nga m. Okay, integer man tong m, start from 0 up to infinity. So ang solution sa r is katong a m r to the m plus b sub m over r to the m minus 1. And then the theta solution is katong p sub m cosine theta. Okay? Ano siya ang solution sa ang taning pm, that's the Legendre polynomial for the theta part. Okay? So this is now the solution sa potential. A solution sa Laplace equation is spherical polar coordinates. So we can get the potential using this equation. Okay? Let's have an example. So that will be example 3. Okay, so given, so natin given nga sphere, tapos na siya potential of this form. k cosine 3 theta. So given this potential at the surface of the sphere where k is constant, so naatay problem dayon. So find the potential inside the sphere. The next is you find the surface charge density. Okay, surface charge density of the sphere. Okay, so let's have a solution for this. Okay, so atong gamiton ang katong solution niya na atong na-solve na daan. We have the summation m equals summation of these values from where m is from 0 up to infinity. We have a sub m r to the m plus b sub m r to the m plus 1 times katong solution sa katong angular part, the Legendre polynomial. Okay. Now, we want to find the potential inside. So, sa letter A. So, for letter A, so let's consider R less than R. Okay? Because, let's say R is the sphere. Surface of the sphere, this is of radius R. Okay? So, consider the potential inside. So, that would mean R is less than big R. So, if R is less than big R, then given sa kanina equation, katong potential, given this one, it should be nga ang B sub M ay 0, right? So for R less than R less than big R, meaning inside sa sphere, kani siya dapat, na term should be 0. Why? Because if R is less than R, then let's say ang small r ma-approach to 0, then this would blow up, right? So mudako siya, then that should not be. So potential there should be finite, not infinite. Okay. So in order to avoid that, dapat ma-zero na siya. Okay. So we have to make this 0 for potential if you want to find the potential inside. So ma-simplify ang ato ang equation. Have this one. So you're only left with this constant am. Sorry. A sub m r to the m, and then the angular part cosine theta. Okay. So next is we want to find kaning constant na am. So where can we find that? So atong gamiton ang boundary condition sa surface. So let's say at r equals r, okay? Di ba at r equals r na aman tani nga potential? Oh, what's happening? Okay, sorry about that. Tara. So at r equals r, meaning at the surface, nakakuha nga potential which is k cosine 3 theta. So, naa siya na specific potential. So, we'll use that. Okay? So, at R equals big R, we mean big R theta equals. So, summation, then this is A sub M. So, this is big R na. Okay? And then PM cosine theta, this is equated to the potential sa surface. K cosine, oh, K cosine 3 theta. Okay? Okay. So, para ma-simplify ni siya, bulag siya na. Okay. So, para ma-simplify na siya, we'll have to recall lahat ng mga side trip and recall your kana siya. So, atong ini-simplify. So, we have cosine 3 theta. So, that is actually, can search it sa internet or sa inyong any math book, specifically Lighthold or TC7 nga books. Kani siya nga equation cosine 3 theta is just equal to 4 cosine cube theta minus 3 cosine theta. Okay? So, para ma-specify lang siya ani siya nga form. And then, we'll look at katong equation na to. Ini siya. Okay? Atong i-relate pa ang cosine theta. Atong i-relate ni siya nga equation. Kaning cosine theta or cosine cube theta with respect to the Legendre equation. Okay? So, in here, x will be substituted with, so what na po ano? Okay. So, x will be substituted as cosine theta, where x squared is cosine squared. So, we have x cubed as cosine cube. Okay? So, going back here, we can see it here na ang uh, ang cosine theta is just equal to P1 of cosine theta, right? Like that din here. Tara. So, n is 1. So, that's n is 1. So, P1 na siya. So, P1 of x is equal to x. Okay, tara. Atong correspondence ba? For n equals 0, P of 0 is 1. Okay. For n equals 1, so P1 of x is x. So, or cosine theta. P2, n equals 2. So, P2 of cosine theta is 1 half 3 cosine squared minus 1 and so on. Okay. I hope follow na siya. So, in this case, cosine theta is P1 of cosine theta. Okay? Now, let's take a look at katong P3. Kinaaman dito ang cosine cube. Tara. So, that would mean 1 half 5 cosine cube minus 3 cosine theta. Okay? That's equivalent to P3. Okay? So, that would mean 1 half 5 cosine cube theta minus 3 cosine theta equals P3. Okay, I hope na-follow ra. And I will simplify this one. Nga dapat ang mabilin diri is cosine cube na lang. So that's cosine cube theta. Atong i-balance sa picas. So we have, so multiply mo siyang 2p3. Right? 2p3 of cosine theta plus 3 cosine theta over 5 Okay, I hope that's clear. So this is actually 2p3 cosine theta plus 3, where cosine theta is just p1, right? P1 cosine theta over 5. So this is cosine cube. So therefore, our cosine 3 theta is equal to, substitute na siya, 4 times cosine cube, that would be 4 times the whole thing, 2p3 cosine theta plus 3p1 cosine theta over 5 minus 3p1 cosine theta. Tama? So this would be, medyo gumot na siya gamay, pero I hope ma-follow na siya. So this would be 8p3 of cosine theta over 5 plus, simplify na siya, 3 over 5 p1 of cosine theta. Whew! So, wala na siya. So, tara. We can see here, tara, French sa taas. So, ang right-hand side sa kaning k cosine theta would be equated to this. Okay? Meaning, this whole thing will be equated by this. Okay? I hope maka-follow na. So, let's do that. So, medyo nag-lag ang whiteboard. Okay. So, we'll rewrite V. So, we are still on this condition nga nasa surface, R equals big R. So, we have 1. A sub m, R to the m, Pm cosine theta. So, ato na siyang i-equate sa katong right-hand side. We have 8k, naman to k, di ba? P3 cosine theta over 5 minus, okay? So, minus din siya di ka. This should be minus there. Sorry about that. This should be minus. Okay, so that will be minus 3 over 5 k p1 of cosine theta. Okay. Now in this case, if you look at the left hand side and the right hand side, ma-equate ra gid na siya if, take a look at this, m, m. This can only happen if ang m nimo is, it's either m is 1 or m is 3. Otherwise, wala kay value sa imuhang left-hand side. Otherwise, am is 0. Right? one-to-one correspondence sa na siya. Kay mao na siya ang result sa right hand side. Mo exist lang ni siya kani, mo exist na siya if kani siya nga form in which ang m equals 3 or m equals 1. Okay? So in that way we can get the constants of a sub m. Okay, let's do that. So let's consider m equals 1. We have a1, right? Then r to the 1. Then sa kani siya nga form. Then we have p1 of cosine theta. Then i-equate lang nimo ang katong p1 ra pod nga kani siya nga form. Okay? Okay, kana naman siya mo na ay actually summation man ni, di ba? Summation siya sa tanan m, but since ang naalay mo exist lang siya nga na summation if ang m tama na siya og 1, even wala ganito 1 nga m o 3 nga m, the rest kay 0. Okay? So this is negative 3 over 5 k p1 cosine theta. I hope clear na siya. Then this cancels out, right? Cancel na siya. So we are left with, ito na i-calculate mo ng a1. a1 is just negative 3 over 5 k over r. Okay, I hope clear na siya. Oops. Balik na sa picas. Next is m equals 3. So we have a3, right? a3. Kani nga equation naman na. Kani. r3. We have p3 cosine theta equals 8 over 5 k. So, mas nindot po siya if while nagtanaw mo nga video, take notes mo para dali na niyo bitaw ma-review asa ko nag-base ani nga equation. So, you have p3 cosine theta. Again, cancel na siya. We are left with this. a3 is just 8 over 5 k over r cubed. Okay? So, we have this equation, we have this form already na ang solution is na-exist lang siya if m equals 3 or m equals 1. Okay? So, na-determine na nato ang am, where ang am is katurang a1 o a3 ang nag-exist. Therefore, the solution okay. So, tanaw na to ang ato na i-substitute una atong sa tara. For this one kani, so we have so the solution is where kani siya nga form, kani siya nga kuan actually ana mag-log na siya na. So for a equals 3, so we have ang a3 na to is kana. Okay? So the solution is just this. 8k over 5, and we have 8k over 5, we have r cubed, katong gikan na siya ani nga katong general form, di ba? R to the m, p to the n, cosine theta, where am is given by this, kana. Then we have m equals 3, we have r cubed. So nakamani r cubed nga dako sa ubos, so we have r cubed p3 cosine theta minus katong m equals 1, 3 over 5k r over r, p1 cosine theta. So this is the solution. Okay, this is the overall solution. So this is for r less than r. Okay? For so solution na siya inside. Okay? Now, patanahuman. How about for the potential outside the sphere? So r greater than r. So let's find out. Saan na siya? So for r, vlog na siya da. Okay? So for r greater than r, meaning for potential outside, balik ta sa atong solution. Sa atong solution gani. General solution. Mababa na siya. So for r greater than r, given this solution, a sub m this time around should be 0, or else v will be infinite. Okay, we don't want that. Tara, for r greater than r, if we extend na ang r to infinity, so there's no way nga mo infinite ang potential. Dapat mo 0 man dapat ang potential if naka sa infinite. So para mo avoid na siya, kailangan na to siya kaning a sub m is set to 0. So simplify na po ang ato ang solution becomes this. So bm na lang nabilin. M plus 1 bm cosine theta. So para makuha na po nato ang constants nga b sub m, so let's make use na po of the boundary condition at the surface. So at r is equal to r, okay, we have r that becomes v sub m over r, big R to the m plus 1 times v sub m cosine theta. This is equal to the katong na-solve naman nato ganina, automatic nato gamiton katong sa inside dito. 8k over 5 p3 cosine theta minus 3 over 5 p1 of cosine theta. Alright? Again, if you look at the left-hand side and the right-hand side, the summation can only exist if m equals 1 or m equals 3. Okay? m should be equal to 1 or m is 3. Otherwise, bm is 0. So, wala siya value. So, wala man na ang pasabot ani nga equation. The summation here is equal to this equation. So, meaning, dili tanan m nag-exist. Okay, ang m, according to this equation sa left-hand side, m runs from 0 to infinity. Pero pag abot mo sa right-hand side, mo equate today siya og kani duha ka term lang, meaning m equals 1 and m equals 3. The rest is 0. Okay? So let's consider first m equals 1. So we have b1 over r squared p1 cosine theta. That's equated to kani siya nga term 3 over 5 p1 cosine theta. So cancel, b1 is therefore negative 3 over 5 k r squared. Okay. So muna ang b1. For 3, m equals 3, so we have b3 over r to the 4 p3 cosine theta. So kano siya nga equation D, P ka na siya diri ha. Left hand side equals this one na dayon kani 8 over 5 k r to the 4 p3 cosine theta, so cancel ang kaning p3. Therefore b3 is just 8 over 5 k wala na siya r to the 4, sorry. Tara naman na siya kani. So this is r to the 4. Okay, muna ang b3. So we have the constants b1 and b3. It is lag. Asan na to? Tara. So we can now calculate for the potential. So this is just negative 3 over 5, negative 3 over 5k r squared over r squared p1. If you have question, you can comment lang ha, or message me sa Facebook. Plus 8 over 5 k r to the 4 small r to the 4 p3 cosine theta. So this is now the equation. Okay. So this is for this is for r greater than r, okay, meaning outside. Okay. So man, that's the potential for the outside. Next is atong pangitaon pa nato, di ba? Ang last question sa problem is the charge density. Okay. So what is the charge density at the surface? So that can be solved from this formula. Itong electric field this is electric field outside na lang. Outside the sphere minus electric field inside the sphere. So that's actually discontinuous given by this. Or kay mo man tangan natin ani nga formula negative del v. So kani nga equation is just actually del or the derivative. So we have v with respect to r. Okay, this is r outside r inside. Okay, this is negative del negative sigma over epsilon naught. So this is how we will get the charge density from this formula. Okay, So we need to evaluate the potential. So ito isa-isahon. Let's consider first the potential outside. So consider itong outside. So you can refer to the katong formula ha din kumusta ka sa taas kay mo mag-lag siya. So namatay so duha ka solution di pa sa potential inside and outside. We'll make use of that. So katong formula sa potential formula sa atong potential outside, we take the derivative of that with respect to r, and katong potential sa sphere inside, we take the derivative of that with respect to r. Tapos i-minus nimo ang duha, you get this, kani negative sigma over epsilon naught. So kamo na lay bahala ani og check basta kay ang result ani niya is for the potential v with respect to r, ako na lang imutang ha. So that would be 6 over 5 k r squared over r cubed. So mag-log na yun siya. Cosine theta v minus. So pag derivative na siya. So we get this. Then evaluate that. Ang small r, mahimo siyang big R. So mahimo na siyang, can check it later on na lang. We have k over 5r. So after simplifying, we have 6 p1 of cosine theta minus 32 p3 of cosine theta. Okay. Now for the inside, this is inside. So you get you get 24 kr squared over 5r cubed. We have p3 cosine theta minus 3k over 5 p1 of cosine theta over r, then evaluated at r, big R. Okay, so if i-minus nimo na siya, so we have katong r outside kaning o ang r inside, you get this one, k over 5r. So we have 9 p1 of cosine theta minus 56 p3 of cosine theta. This is equated to negative sigma of theta over epsilon naught. So equating that one, we can get this sigma. Okay, just the sigma is just positive k epsilon naught over 5r times negative 9 p1 of cosine theta plus 56 p3 cosine theta. So that will be the final form sa tuang. This will be the charge density distribution sa surface. Okay? So I hope that is clear and naka-follow na mo. And if you have questions, you can raise that question sa Facebook Messenger, or you can set an appointment para mag-Google Meet if you like that, para maka maka-set an appointment. Okay? So that would be all, and see you on my next vid para sa part 3. Naapat yung part 3, that is separation of variables in cylindrical coordinates. So we are done with the Cartesian, spherical, and then this time, next na lesson would be in cylindrical coordinates. Okay, thank you, and God bless.